Hey everyone, welcome back to our next section going through ions. So we just took a look at the periodic table and going through periodic trends, and then we're going to kind of continue on and talk about ionic compounds, valence electrons, and how bonds are formed. So using the work of Mendelcev, scientists learned that all of the elements within each group have the same number of valence electrons. Remember, our groups are our columns, they go up and down. So within those columns, we have the same number of electrons in the outermost shell, in those valence shell to count out the electrons, which would be those valence electrons. So from our work in Chapter 5, going through orbitals and highest occupied energy levels and all that kind of stuff, valence electrons are the electrons in that highest occupied energy level in an element's atoms. So the valence electrons can be found by looking at the representative elements and their group numbers that are there. And so if we take a look at our periodic table, you'll notice up on the top there's some Roman numerals with the letter A. Those are our representative elements. So valence electrons are usually the only electrons that are used when we start to interact them to make chemical bonds. So normally we tend to show these by electron dot structures. In the past you've used Bohr diagrams, and those Bohr diagrams would kind of show pictorially how many electrons are in the outside shell, but a lot of the time the protons, they don't really change. The neutrons might change if it's an isotope. But for the most part, in terms of reactivity, we're concerned with those valence electrons. So electron dot structures are diagrams that can show valence electrons as dots. So if we were to take a look through the first 20 elements here in the table, what we would see is that hydrogen has one valence electron in its outside shell, helium has two, and so remember in that first shell, if you remember Bohr diagrams from before, helium in that first row, it's two electrons, but actually fulfill a stable ion for helium, or a stable atom for helium, not an ion really. Lithium has one electron in its outside shell, beryllium has two, and then this is skipping the transition metals, and we're just looking at those representative elements, and so we're moving into boron, which is in 5A. And so you can see how it just has 3, and then it just keeps increasing, 4, 5, 6, 7, until it's finally full in 8. If we go down to sodium, you can see again it just keeps increasing, and so if we were to look in every group, okay, up and down, we can see that they all have, in the first row, in the alkali metals, they all have 1, alkali earth metals all have 2, and then 3, 4, and so on, going through the list. So all of these are the electrons that are just in the outside shell. They're the valence electrons. So there's this idea of an octet rule. In forming compounds, atoms tend to achieve the electron configuration of a noble gas. Atoms and metals, they tend to lose their valence electrons, leaving a complete octet in the next lowest energy level. So metals in general, they tend to lose valence electrons, whereas atoms of nonmetals, they tend to gain electrons or share electrons with another nonmetal to achieve this complete octet structure. So it's always kind of looking to fulfill a shell of 8 around the outside, and this idea of an octet structure. So we have the formation of cations. So an ion forms when an atom or a group of atoms, when they gain or lose electrons. An atom's loss of valence electrons produces a cation, and cations are known as positively charged particles or positively charged ions. So cations match in with our metal group, because metals tend to lose electrons. So your metals as an ion would be a cation. So in the textbook, on page 188, 189, and 190, there's a little bit to read, just to go through the bottom of page 188, and then page 189 and 190. And then what I'm looking for you guys to do is to summarize just a few points, it doesn't have to be a lot, on what happens to sodium and magnesium. Okay, so pause the video, go through, take a look at it, and come back after you've made a couple of points. Alright, so hopefully you've had a chance to see how sodium and magnesium, how they form cations. And so we can move on and kind of take a look at the formation of anions. So an anion is the opposite of a cation. It has a negative charge to it. So the gain of negatively charged electrons by a neutral atom produces this anion. And when we're dealing with ionic compounds, typically the name tends to end in IDE. So take a minute and read pages 191 and 192. And the same kind of thing as before, summarize in just a few points, basically to your understanding, on what happens to chlorine and oxygen. So just take a second, pause the video, make a couple of notes. It doesn't have to be a lot, just a few notes, and come back when you're ready. Alright, so the last part of this section, there's a couple of questions that just kind of connect this together. It's 1 through 11 on page 193. So just let me know if you have any questions, and good luck.